Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan good evening. Okay, good evening to all of you. Right, so actually our syllabus already finished. Okay, that's it. So now we just focus on the tutorial. Okay, today we go for the tutorial 4. Yeah, tutorial 4. So all the lecture or tutorial before this, so you can watch in my YouTube. Alright, my YouTube channel. Alright, so today we go for the tutorial chapter 4 lah. I think you have already the document, the tutorial 4. So let's discuss about the tutorial 4. Right. So we go for the question number 1. So the tutorial 4, I will copy first. Okay. I will copy the question first. Question first. Right. So this is question number 1. Question number 1, tutorial 4. Right, so the full adder in the figure 4.1 is tested under the all input condition. Alright, so given the input A, B, and C ins, okay, with the input wave function this one, right, or the given, and then from your observation of the submission, alright, submit and the C out waveform already given the C in, okay, the sum, okay, the output and the C out, okay, is the operating properly? Is it correct or not? Okay, so this question, is it correct or not? So you have to double check, is it, so for the carry and the out, sum out here, is that correct or not? So you have to double check lah. Okay, if not, what is the suppose the output for this one lah, for the output here, and then carry out lah. Okay, carry out and the sum lah here. Okay, so based on the table, okay, for the full adder, so maybe you can refer to the slide, right? Slide on the full adder. Okay, so this is a full adder. So this is full adder. All right. Okay, so this is full adder type of diagram. Okay, full adder, full adder, full adder, uh, full adder. Table, right? Right. So as you can see here, so here is a 0, 0, 0. Okay, the first is a 0, 0, 0. So 0, 0, 0, and then sum will be 0, and then C out will be 0 lah. Right. So sum will be 0. Okay, the first sequence is a 0, 0, 0, and then will be 0, 0. Okay, second sequence will be 0, 0, 1. Means 1, 0, 0. Okay, 1, 0. So this one will be C in. Okay, we follow this one. Okay, this one will be A, and then this one will be B, and this one X and Y lah. Or we put as the sum. This one is the sum. Or maybe I can put as follow this table. So we put okay. So this one we put as the C out, carry out, and this one will be sum. Will be sum. Okay, so 1, 0, 0, 1, 0, 0 will be here. Okay, will be here. All right, so the output will be 0, 1. So 0, 1. Okay, 0, 1. Next, here will be 0, 1, 0. Okay, okay, 0, 0, 1. Because B here is 1. So I just follow from this table lah. Okay, so 0, 0, 1. So 0, 0, 1. So will be 0, 1 lah. Okay, 0, 1. Right, next, follow this one will be 0, 1, 1. Okay, 0, 1, 1. C in is a 1, B is 1, A is a 0. Okay, it means 0, 1, 0, 1, 1, 0, 1. 1, 0, 1 will be 1, 0. 1, 0. Okay, so next will be 1, 0, 0. Okay, so this sini is 0, B, A is a 1, and then B is a 0 lah. Okay, make sure so because of this one will be A and this one will be B, so I just follow this table lah. So you can just based on this table we can get the input and see out and the sum lah. Alright, so 0, 1, 0. Okay, 0, 1, 0. So the output will be 0, 1, 0, 1, 0, 1. Okay, next will be 1, 0, 1, 1, 0, 1. So C will be 1. Alright, so B will be 0, and then A will be 1 lah. 1, 1, 0, 1, 1, 0. So will be 1, 0. So I think the rest we can proceed. Okay, just some example here. So we know 0, 0, 0. Okay, for C out will be 0. Okay, so 0, 0. Okay, so will be 0, 0, 1. Sorry. So not so nice, not so nice. Right, sorry. Okay, CR. Okay, CR will be 0, 0, 0, 1, 0, 1, 0 lah. Okay, so this one we have 0, 0, 0, 1, 0, 1. So and then for this one for C out lah. Then for sum will be 0, 1, 1, 0, 1, 0. Okay, this one 0, 1, 1, 0, 1, 0. Okay, so this is uncorrect. Okay, so this waveform is uncorrect. The both for sum and the carry out will be wrong. So this is correct. So we have to continue. So we have another another output here. So okay, so the out. Okay, so the out will be alright. So the rest two will be 1. The rest is the 1, 1. Okay, and then for one will be 0, 0, 1. Okay, so this is a 0, 1. Okay, 0, 1. Okay, so this is the correct the correct answer for the waveform. For the waveform for the carry out and for the sum for full adder. Okay, alright. So go for the next. Okay, for the next question will be question number 2. Okay. So question number 2 will be BCD numbers. Okay, BCD is a binary coded decimal numbers are applied sequentially to the BCD to decimal decoder. So now we use the decoder as you can see in the figure 4.2. So this is our decoder. Okay, so draw the timing diagram. Show each output in the proper relationship, okay, between the others and the input. So that means you have to draw the output. Okay, the output follow this input. For example, the input currently now, okay, for example, initial is a 0, 0, 0, 0. Okay, so 0, 0, 0. So will be okay. So this is we call that active low. The active low, that means the output will be 0. Active will be 0, and then 1 will be not active because you have see the bubble here. So this one we call the active low. So will be 0. Okay, that's why okay you can see here. So the 0 will be first. Okay, 0, 0, 0 will be 0. So okay, on the here will be activate lah. Okay, will be activate. Activate is a 0 lah. Okay, will be 0. This one is 0. 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. I just follow this one. So it's quite tough to draw following the pin. So I just draw this here. Alright, so next sequence will be 0, 0, 0, 1. Okay, 0, 0, 1. That means would be 8. Okay, 8 will be active lah. Okay, you can see here 8 so 1, so this thing will be 1, 0, 0, 0. Okay, 1, 0, 0 will be 8. All right, so for 8 will be the, okay, this one, the rest will be 1. Okay, the rest will be 1, 1, 1, 1, 1, 1, 1, 1 for the first sequence 1. Okay, but for the second here will be active on the 8th. Okay, this one will be 0 lah, 0 so the rest will be continue 1 because active low active low, this one will be high lah. Okay, high, 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 high. Okay, for second sequence, sorry, too long. Okay, and then we go for the next sequence lah. Next sequence will be 0, 0, 1, 0. Okay, means 0, 1, 0, 0. Okay, this one will be 4. Okay, this one will be 4. Will be active at 4 lah. 4 here for sequence number 3 will be 0. The rest will be maintained high, maintain high, maintain high, maintain high, maintain high, high, maintain high, high, okay, high, and high. Right. So next sequence, you can see the next sequence will be 0, 1, 0, 0. Okay. 0, 0, 1, 0. Okay. 0, 0 is a 2. 2. So this means 2 will be active low. Active low. Rest will be follow high lah. High, 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 high. All right. So next sequence, I will show next I will show that's okay, example, then rest you can try lah. So this one will be 0, 1, 1, 0. Okay, 0, 1, 1, 0. Okay, this one will be 6. So this one 4, and this one will be 2. Will be 6. So active at the 6. Okay, so number 6. So active will be 0 lah. So the rest will be high, active high. Okay. This one will be high. Okay, okay, high. So this is the pin for the every pin from the 0 to 9. All right, you can see this one so you can continue lah, continue this one. For example, now we have the 1, 0, 0, 1, 1, 0, 0, 1. This is 8, 9, 9 lah. So at the 9 will be active low. Okay, the rest will be active high. Okay, the rest will be active high. Okay, hopefully you can get this, and then the rest, okay, this one, the rest you can try this one so follow the input here lah. Next will be 1, 0, 0, 1. Okay, that already here lah. The next will be 0, 1, 0, 0. Okay, so will be similar with okay, will be similar like this will be 8 then continue and so on. Okay, so that is therefore question number 2. Okay, next we go for the question number 3. All right, so this is question number 3. Okay, referring to figure 4.3, show the input and output bits. Okay, for the following 4 bits input numbers, if C0 here, C out here, C0, or we call it C0, will be connected to the ground. So when connected to the ground, that means C0 will be 0. Okay, so you can see this one. All right, so as you can see here, the input here will be right. So this one you can declare as the A. Okay, this one maybe you can declare as A, and this one will be B lah. Right, so for example 1, 1, 0, 0. Okay, so this one for A3, A2, A1, A0, and then plus with, okay, this one will be plus plus with 0, 1, 0, 1. Okay, so just plus 1, okay, 0, 0, 0, okay, carry 1 here. right? So this one will be the output lah. Output this one, so as you can see here, so this one, okay, this one will be S0, S1, S2, S3, and this is the carry C4. Okay, carry C4. C4 will be 1. Okay, S0 will be 1, 0, 0. So this one will be S0, S1, S2, S3, and this one, the carry will be C4 lah. Okay, so this is a carry C4, and then we can see this one. Okay, second, we have the, you have to remember lah, if we have the negative, so we have to use the second complement, second complement to uh, to do to this operation lah. All right, so this is some application using the uh, adder, using the adder. So we convert into the second second complement. First, you have to convert the first complement 0, 0, 1, 1. So you have to know, we have to remember 0, 1, 1, 0, 0, then plus 1. So this is a first complement, first complement, then plus 1 will be second complement. So this is the output. So you have to remember. So to convert, okay, this one because of negative, okay, they mentioned to you. So that's why we have to, because of some computer, it's not recognize this negative. So we have to change to positive. So that's why we use the second complement to change from negative to positive. Then the output will be okay, 1, 0, 1, 1. Right. So this is the uh, input for this one. And then we just add 0, 0, 1, and then 1, 1, 0, 1. Okay. So this one will be 0, bring 1, 1, 1, 1. Alright. So no carry. So we assume as a 0 lah. So this one will be S0, S1, S2, S3, and C4. Alright. So you get that. Okay. So 0, 1, 1, 1. All right, so this is question number 3. All right. Okay, so I go for the next question. I think question number 4. Question number 4. I copy the question number 4 first. Okay, will be, I think question number 4 also similar lah. Okay, also similar with question number 3. Okay, so question number 4. Okay, use the diagram in the figure 4.4 to form an additional of the decimal number by using binary addition. So show the input and output bits for following 4 bit input number if C0 will be connected to the 5 volts. Okay, positive 5 volt, that's mean 1. If ground would be 0, and then for plus 1 for the connect to the connected to the 5 volt, that means connected to the 1. Okay, all right. So I think this is a straightforward. So first, all right, for example here, okay, you have to convert into, okay, this one actually is the positive, you convert into the binary. All right. For example, I 0, 1, and okay, for the 5, okay, 4 plus 1 will be 5, and then okay, I put as a negative first, 0, 1, 1, 1. This is for 7. For 7. Now we have the negative here, so this part we have to convert into the second complement. Convert to second complement. 1, 0, 0, 0. Okay, plus 1. Okay, will be 1, 0, 0, 1. Okay, and then we have to plus 1, 0, 1, 0, 1, 0, 0, 1. Okay, so 0, 1. Okay, 1, 1, 1. Right, so the answer will be 1, 1, 1, 0. This one, C0 will be 0 lah, so no carry here. So assume as a 0 because of no carry. Okay, just 0. So this one will be S0, S1, this one S1, S2, S1, S1, S2, S3 lah. This one S3, and this one will be C4. Okay, this one will be C4. So similar like this one. Okay, I think this one you can try lah. Okay, just give some example, not all. So because we have to try also. We have to convert this one. Okay, we have to convert to the second complement. Then after you convert second complement, right, then you can add, and then so the carry here, all right, actually is the for the C4 lah, for C4. Okay, so this is question number 4. So we go for the next question number 5. Okay, all right. So question number 5 will be okay. Just show the IC, yeah, the connection of IC. I think this is very simple. Okay. All right. So the question number 5 will be show the three IC for 74LS to 83 adders can be connected to the form in the 12-bit parallel adder. All right. So this one we just draw the IC lah, the IC for the okay. So we have a 5 bit. So that means if this IC will be on, we have the 4. Okay, so for example, like this, we have 3. Okay, this one number 1, number 2, number 3. Okay, for this IC. Okay, this IC number 3. All right, so we have this one lah, A, B, C, D. Okay, this one we have another. Okay. This one for A, this one for B. For A, okay. The one for B, one same for A. Then another one for B. All right, so the output, the output will be okay, and then this one also the output. And this one the output lah. We have 4 output. Okay, and then this one the carry. Okay, carry C naught. Okay, so carry naught will be 0, and then this one will be carry C4 will be continued to the C naught here. Okay, C4 similar like this one. So this one will be C4 connect to the C1. Okay, so this one will be go to the output lah. All right, so this is the okay, this we call the IC lah. This IC, okay, 74LS 283 lah. All right, so this is for example like pin number A, and then this pin number B. So this one A B A B. Right, so this output will be 1 2 3 4 1 2 3 4 1 2 3 4 lah. So this is the connection for the 3 IC. All right, so next we go for the question number 6. Okay, question number 6. All right, okay. Okay, question number 6 is a long question. So we have the set question, so you can download to the team or the upload the tutorial. All right, so this is question number 6. Okay, as you can see here. All right. Okay, so this is question number 6. Question number 6. Okay, question number 6. Reference to the figure 4.5 following the specification of the required decoder. All right, so you can see this one. So if okay, so this is a parameter that we have to know. So you can see if the input okay, if you are okay, it's a 0 0 0. Okay, nothing is displayed lah. Nothing is displayed, but if the input 0 0 1, yeah, I think this is a ABC. ABC here. Present as the ABC. Okay, input as the ABC. I will check the question. So, okay, suppose ABC lah. So if okay, so if the input is 0 0 1, okay, the letter A will be displayed. Then next will be 0 1 0 will be B, C, and so on stuff. So when the input 1 1 1, consider as the invalid situation lah. Right, invalid situation. Okay, so the question number 1. Okay, so you have to build the truth table of the required decoder. Okay, for the okay, so this one will be using the 7-segment display unit, use is of the command type. Okay, the command type already given here. So the command and not type will be 0. 0 will be active. Okay, 0 will be active. Like I mentioned to you, is the active low. Active low. That means 0 will be we have to active. If active high, so we use the 1. But this one active active low, so we have to use 0 to active the, because we use the common and common and not type, right? So the first we have to develop the truth table. Okay, so based on uh, the here given here, so we know that 0, 0, 0. The first condition, maybe we can put this one A, B, C. All right. So next, right. So 0, 0, 0. So we said that nothing happened. So no display. So no display. All right. So for example, our okay. So maybe you have to remember lah. So the sequence for this the LCD is A. So for A, B, B, C, D, E, F, G. So that means here we have A, B, C, D, E, F, G. So no, if no display, that means all one. Okay, so no active high. So because we use the cannot end up, that means the active will be 0 lah. So this one will be not active, so will be 1. And then next sequence will be we assume as the 0, 0, 1 lah. 0, 0, 1. Okay, 0, 0, 1 will be at, okay, will be display 1. We display A lah, we consider A. So A will be only this one, only D do not okay, only D will be display lah. The rest will be display. So okay, for A, for example, so this one is a 0, will be display is a 0. Sorry, not this means here no display, no display lah. This means LED will be not on. Okay, this one will be display lah. Okay, sorry, this one will be display A will be like this lah. Okay, it's a capital A lah. You see, let's say capital A. Right, so this one, so only D. This one only D, not active lah. So will be 1 lah. Okay, the rest will be 0. The rest will be on lah. Okay, second will be 0, 1, 0. Okay, 0, 1, 0, 0, 1, 0 will be B. Okay, so B will be like this. Okay, maybe we use the small b lah. Okay, okay, small b. So that means will be on for the C, D, E, F, G. Okay, okay. So A, B will be off. The rest will be on. Okay. All right. So next sequence will be 0, 1, 1. 0, 1, 1 will be display C. C like this. C like this. Yeah, like this. So that means will be on the A on, B 0, okay, C 0, D on, E on, F on, G 0. Alright, so that is for C lah. This one for C, one for B, this one for A, and then this one is not LED on, right? Will be 0 display. So next will be D, for example, 1, 0, 0 for D. So for D, maybe we use the small d lah. We use a small d to make, okay, like this. Okay, so D, right? So A will be on. Sorry, A will be off. Okay, will be off. Will be on lah. Oh, sorry, will be off, but will be 1 lah. The value is 1 because of the so this one will be 1. Okay, B will be on, C will be on, D will be on, E will be on, F will be 0, G will be on lah. Alright, so circle D. And continue, we can continue lah. Next, we can continue 1, 0, 1. Okay, 1, 1, 1 lah. Okay, 1, 1, 1. Alright, so you can see 1, 1, 1 is the invalid. So invalid is the don't care lah. You can put as the don't care. Alright, so maybe I could proceed for the another one. Also, okay, so okay, this one will be F. F up to you lah. Maybe you can say 2 lah. Something like this. Okay, this means will be on. A will be on. B off. Sorry, on will be 1. On will be 0. Sorry. Okay, that's why you have to double check. Alright, so F, A will be on, okay, B will be off, C will be off, D will be off, E will be on, and on. Okay, alright, so that is the truth table for this sequence. For the sequence from 0, okay, that means from no display, A, B, C, D, F, and then for 111 will be easily. Alright, so next we have to do the truth table, the K-map to get the every one. So this one will be I will show maybe some between this one to this one, and then the rest you can try lah. And then the rest, this one the input with P, the input will be C, this input will be D, F, G, and so on. Okay, so you can draw the truth table. Okay, so for example, you have the A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay, we have to remember for the K maps. Right, so based on this one, I will say 1, 1, 0, 1, 0, x 0, 0. Okay, so this one we use the 0. Okay, we use the 0. So you have to remember, if you use the 0, that means we focus on the post. Okay, you focus on the product of some standard form. So we focus on the post. If 1, that means we focus on the sum. Right, so that's why we have to plot on the 0 lah. Okay, on the 0, that means here we assume this x will be 1. Right, 1, and then the one will be here. Okay, assume x as a 1 because don't care can be 1 or can be 0. Then we can get the A, the input of A will be A bar plus B bar. So this is in the post, in the post and C bar. Okay, then you can draw the this so we draw the circle. So example, we have the A bar here, we have B bar here, and then we have another one C bar. So we have A, B, C. So this one, we have another one go for the O. Okay, and then another one we have the N. Oh, sorry, N. Okay, all right. So this one will be okay lah. All right. So this one Next we can try for the okay, this one for A, and then next we could go for the B. For example, I will show another example, then the rest we can try lah. Alright, so we have A, B, C, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0. For second, for B is a 1, 1, 1, 0, 1, x, 1, 0. Alright, so this one, okay. So we just only this one, and then the one. Okay, because of this is supposed, so we have to put on the 0. So the output B will be okay, this one and this one. So will be A plus B plus C bar, and then multiplied by A bar plus B plus C. Alright, A bar plus B plus C. So you can draw lah. Okay, from A. Okay, we have the B, C, we have only one. We go for 4. A, B, C bar. Alright. Another one. So another one. Then we go for the N. Alright, so this one A bar. So this is for A. We have A. And connect to this one B. Then C is from C. Alright, so the A, B, C. Okay, so this is the graph, the graph for B, for the B here, right, for the B output B. Okay, so the rest you can try lah, So for the C, D, E, and until for the G lah, that is the question, Okay, the draw the circuit for each of the segment, So every segment they have the circuit there. So okay, so that is question number 6. Okay, so we can go for the next. Okay, next question. Okay, next will be question number 7. Okay, number 7 I think will be same. Okay, will be same. Okay, so will be same. Alright, so number 7. Okay. Because number 7 I think similar like question number 6. Okay, design of the decoder. The specification of the required decoder is given below. Right, if the input AB 00 equal to 00, that's the display number of 0. Okay, number of 0. Then for input 01, it will be display number 1. And then so also 10 will be display number 2, number 3. Okay, so this one, okay, this 7 segment display unit use common cathode type. That means active high. Active high here. Okay, use one. Logic one. So active high logic one. Okay, we use logic one. First, you have to similar like question number 6. You have to develop the truth table. Okay, this one would be we have the A B. This one 0 0. Okay, so this one will be A B C D E F G. Alright, so now if display 0, number 0. Okay, so number 0 will be okay, and only G is not okay. This is our segment. Similar like okay, segment A B C D E F G. Alright, for the first, it will display number 0, something like this. 0, Okay, so now only G is not active. The rest will be active. Okay, so next equal will be 0 1. 0 1, number 1. So maybe number 1 like this. Okay, like this. Maybe you can put B and C on the this one, B and C. B and C. The rest will be 0. Okay. Next, you can see next is 1 0 display number 2. So number 2 something like design something like this. Something like this. Number 2. This name will be on A on, B on, C 0, B on, F B on, F0, B on. Okay. Right, so this is the for number 2, and then number 1 1, display 1 1 will be display 3 lah. Display 3 will be like this. Okay, will be 3 something like this lah. Only F and E not active, the rest will be active, right? Yeah. Okay. So next you can draw. You can draw the for example. Next you can use the K maps. Okay. The K maps. Okay. I will use some example here. So you have the A B. we have only 4 here. 0 1 0 1. I put, see for example here, because of this one I put here, okay, the B here, so because of 1 1 1 1, so 1 1 1 we just put here, so B is the 1, okay, 1, all right. So for A, okay, for A, we should A B, okay, 0 1 1, okay, uh, 0 0 0 0 1 1 0 2 0 1 0 1 1. Okay, so this one will be like this, A equals to B bar plus, so will be A plus B bar lah. Okay, alright, so okay, next you can try lah. Okay, next for the C, alright, so you can plot, okay, similar like this, then you get the simplified tabular expression. So on this, so you have this one, we have no lah. So the step for this one, okay, this one will be straight. Okay, so this one B, right, will be straight, and this one we have A. Okay, we have A, and we have the object here. So and then we have not for B. Okay, so this is for A. This is A. Is it okay? Right. So the rest you can try, eh? The rest, okay. The rest you have to try lah. Okay, so this is for question number 7. Alright, so next we have the time, so we go for the next, okay. Question number 8, okay. Question number 8. Alright, so the question number 8, design of a binary encoder, okay, with priority. So the distribution of the required encoder is given below. So A is the most significant bit, most significant bit. Okay, most significant bit at the, okay, you have to know lah. Normally A is the least significant bit, but here we put as the most significant bit. Okay, you have to know. Alright, let's see. Okay, now we declare A is the most significant bit. So this is question number. Alright, so this is question number 8. Alright, question number 8. Okay, the first, similar like question number 7. Okay, we have to draw the truth table. Okay, so this is number 8. Okay, draw the, we have 4. Okay, this one we have long okay, solution here, because we have a 4 input. We have A, B, C, D. Alright, so and then the output will be X, Y. Alright, so based on this one, so you can see, so you can maybe first you can put as the sequence 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1 1 0 0 0 1 0 1 1 0 1 0 0 1 1 1 0 0 0 0 1 1 1 1. Right? All right. Okay. Sorry, here we have 1 1 0 1. Okay. All right. This is this one. So suppose from 0 to 15 lah. Okay, you have to remember lah. So this is the decimal. You can use your calculator to convert into the into the binary. Okay, but you can see the sequence actually. So 0 1 0 1 0 1 0 1. Second we have 2 0 0 1 1. For we have 2 0 2 1. We have 2 0 2 1, and then next will be 4 0 4 1 4 0 4 1, and then next will be 8 0 8 1 lah. Alright, so that is the standard form lah for the sequence from 0 to 15 in binary. So that's why I can check. So based on this one I know, so maybe we have some mistake because suppose okay, so for the least significant bit will be first will be 0 1 0 1 so will be on 1 1 1 on the power of 1, and then second will be 0 0. Okay, we have 2 power of 2 1, okay, because of the 0 0 1 1, and then increase by another 2 will be 4 4 4 so 4 0 4 1 4 0 4 1, and then will be 8 0 will be 8 1 lah. Okay, so based on this one we know, so if a if only A activate is A1 X, okay, only activate A, okay, A will be activate lah. Alright, so this one lah. Alright, so this one will be 0 0. Okay. Then if right, so and then next will be B activate, B activate, B activate here, B activate will be 0 1. Okay, C activate, C activate, C activate again. Here C activate will be 1 0. Okay, and then D activate will be D, D 1 1 1. Okay. Then right, so you can see okay, so for example here, okay, for example, if more than one input is activate, all right, so more than input will be uh, 0 1 lah, will be 0 1 lah. Okay, if not input activate will be 0 0. So this one not input will be 0 0. Okay, this one we have two. If we have two, then more than one activate, so we have the here lah, right, 0 1 0 1, okay, 0 1 0 1, okay, 0 1, okay, 0 1 0 1, okay. Uh, if we have two, okay, 0 1. If others, okay, if no, sorry here. So if no input is activate, okay, no input is activate others, so will be 0 0 lah. Okay, maybe here will be 0 0 0. Okay, okay. This one 0 1 1, we have one here. Okay, the rest will be 0. The rest will be check on the. Okay, so this one we have 0 1 0 0. Okay, we have 1 1 1 1. We have 1 2 3 4 5. 1 2 3 4. Okay, the rest will be 0 lah. Okay, the rest will be 0. Okay, for example, so this is the result lah. Okay, then you can use the KMAP as a solution. Okay, so 7 and 6, 7 and 6. Okay, so like this, but this one we have 4 for equals A B C D depends, or you can put C D A B. Okay, 0 0 0 1 1 1 1 0. That is 0 0 0 1 1 1 1 0. Okay, alright. So this one I get from the for the X for X here. And I put here will be 1 1 1. Okay, because of 3, the rest will be 0 lah. The rest will be 0. So we have 1 and then the 1 here. Okay, so the answer will be for X will be A bar B bar D plus A bar B bar C. Alright. Okay, so you can So I will just give an example, the result, then we can try to double check here. For y will be a bar b plus a bar c d. Alright, c bar. That's the apa the expression lah, the apa bulan expression simplified bulan expression using the KMF, and you can draw lah. Okay, now you can draw using the NOR gate and gate, but I just here I will show you some example using the normal gate lah. This normal. Okay, so we have hand here. You can D and the one we have D lah. So this one D, B and A. Okay, so here we have object here. Okay, then A bar, we have same A bar, B bar. Okay, so we have another vector here, and then C. So we put another one C here. Okay, so that is for X. And then another one for Y. Okay, so that is the circuit lah. But this one, the question will ask you to implement in the NOR lah, universal gate NOR. And then maybe another one using the NAND gate lah. This is universal gate. So you can draw lah. Okay, first you can draw this one for not, and then for N, then for this one, this part for first for not, and then for N, then for the that is step by step lah. For me, later you use draw the normal gate using the not or and, then from that you can convert into the universal gate. Okay, universal gates. All right, so okay, so I think question number 9. All right, question number 9. Okay, I will okay, question number 9 and number 10. I will copy question number 9 and number 10. Okay, so this is question number 9. Okay, show the Boolean function s equals to b plus ac may be implemented using a single 8 to 1 multiplier circuit, sketch the final circuit. Alright, so now you know that this is a s plus b a c. So this is on the you have to remember this one. This is on the SOP, but it's not standard. So how to convert it to the standard? So you have to know lah. So I just so this is not standard, but in the SOP form. Okay, you have to convert into the standard SOP form. So this one you have to refresh. Okay, how to convert? So I will just give the answer. B plus A bar BC plus A B C bar, okay, plus A B C plus A B bar C. Okay, so I just show example here. Okay, so this one we don't have a B, so we have to put the AC multiplied by B plus B bar. Okay, so B plus B bar, that's why you have multiply here, so that's why E A B C, then F A B bar C. Alright, so similar like this one, we don't have the A and C. So first we have to multiply by A, then we have to multiply by C. Then each one the same, we can cancel out. Then this is the final answer for the standard SOP. Right, from this one, we know. Okay, so we have to draw. We have to draw the circuit, the marks. Okay, multiplier. Okay, for example, like okay, we have from 0, 1, 2, 3, 4, 5, 6, 7, 8 until 7. Okay, so this one will be S. Okay, S we have 3. We have the A, B, C. Right. Then the output will be here lah, S. Okay. So the connection will be the active. This one will be active lah. Okay, we active will be connect to the ground. Connect to the voltage. Okay, so this one we have VCC. Okay, VCC. So which one? So 0, 1, 0. 0, 1, 0 will be 2, so 2. Okay, this one 0 1 1, 0 1 1 will be 3. Okay, and then 1 1 1 1 0 1 1 0 is a 6 number, and then 1 1 1 1 7. Okay, then 1 0 1 1 0 1 will be 5. Okay, the rest are connected to the ground. Okay, this one will be ground lah. Okay, so this is a 8 to 1 marks. This is a ground lah. Okay, this is a VCC. Okay, that's it. Alright, so this is question number 9. And then question number 10, implement the same function as the problem 9 using the 4 to 1 multiplier. Sketch the final circle. Final circle. Okay, now we assume that A and B as the selector. Alright, this one. Okay, based on this one. Okay, so first we know that this is on the not standard SOP format. You have to convert into this one. Alright, so we have to refer to the C lah, because the selector now we have only B and C. Okay, so the selector question number 10. Okay, so here we put the alright. So okay, based on the answer, actually this answer will be okay based on this one. Actually, is the B and C is as the selector. B and C is the selector lah, based on the schema given to me with the selector lah. Okay, so this is S1. We can declare S1. S0 is the BC. Okay, then this is S. Alright, so the VCC is a pin number 0 1 2 3. Okay, so will be 1 and dot will be 0. Okay, this one will be VCC. Okay, number 2. Okay, number 2 we go for the A. Okay, and then for the not, okay, A for the not will be for the number 3. Alright, so if you don't get this one, okay, how to get this one? So maybe you can go back to the previous one. For example, we have the, let me see, we have the A, B, C, and then this is the S. Okay, then you can follow the sequence 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 0 1 1 1 1 0 1 1. Okay, divide by 2. 1 1 1 1. Okay. Alright, so that we have to remember that for this one, okay, how to get the and then this one, okay, this one the 0 1 0 0 1 0 0 1 0 1 0 1 1 0 1 1 1. Okay, and then that's why here we can get 0 1 2 3. Okay, make 1 by 0 1 2 3. That's why here we can get the okay, the 1 here. Okay, and then another one here, 1 1 0 1 1 1 1 1 1 0. Okay, so 1 1 1. Okay, this one will be also 1. Okay, and then 1 1 1 1 1. Okay, and then this is a 1 0 1 1 0 1. Okay, so the rest will be okay. Suppose this one will be 0 1. Okay, this one will be 1. Okay, so I think we have some mistake here. So okay, and then this one for active, so we have to focus for the A. Okay, this one, the A. Alright, so this one will be A. Will be A. A. Alright. Okay, so maybe here we have some mistake here. Okay, some mistake because of okay, based on this one. Suppose okay, this one, okay, this one zero, okay, zero ground right, one right, and then this one for A. Okay, number two is the output will be A, yes, right, and then number three, okay, this one, alright, suppose one one one, okay, this one is right, so we got the 111 based on this equation, we got 111 is right, okay, so it's right, and then 110, which one? 11, you have 110. Okay, so we have another one here. So I think this is correct lah. So this one is wrong. So we have here. So the correct answer will be, because we refer to the B and C. Okay, we refer to B and C. Okay, after that I will show some example. We refer to the based on this one, based on this here, we refer to the A and B lah. Okay, this one. Okay, so this one, suppose this go for the A, and then this is for the one. Okay, for the number three, go for the one. Okay, that is the correct lah based on this one. Okay, but if we refer B, A and B, okay, refer A and B as a selector. Okay, that means the output will be here will be C lah. Okay, we will draw another one. If okay, so this one S1 is not, will be A and B lah. Okay, so this one S, so this one 0, 1, 2, 3. Alright, so now we focus on the C. Okay, we focus on the C. So will be same. Okay, so will be same. It's the 0. Okay, so this one will be 0. Sorry, 0 will be ground. Okay, and then this one will be 1. This one will be VCC. Alright, so this one, okay, this one 0, 1, 0, 1 here. Will be here. So this one will be C. Okay, this one will be C. So we C, go for the C. Alright, so this one, okay, so actually the boss is the 1, 1, 1, 1, so it's a 1 suppose. Okay, so the 1, go for the VCC. Similar like this one, okay, so this is for example this one, the answer for this one. Okay, assume A and B is the selector, for this one, A and B is the selector. Okay, right, so I think I stop here, okay, for the part 1, okay, tutorial for part 1. So next I will continue, okay, the tutorial. Right, so I will stop here. Okay, we see you for the next, okay, for the next part. Okay, thank you very much. Okay, assalamualaikum warahmatullahi wabarakatuh.